Howdy class. Today we're going to finish this handout on systems of linear equations. And now we're going to be introducing the idea of a matrix, or specifically an augmented matrix. So look at the system of linear equations right here, and note that we've got certain stand-ins, A1, B1, C1, D1. These would all appear as numbers for a specific system, where X, Y, and Z are the variables, right? And those will always be X, Y, and Z. So we can rewrite this as an augmented matrix like such, right? So note that this dashed line here kind of takes the place of our equal sign. And so you just simply place all of the coefficients in front of X, Y, and Z here, and everything on the right side of the equation goes here. So we can use this to solve systems by using what is called the Gauss-Jordan Elimination method. Now, this is just the same thing as the elimination method we used whenever we would write the equations down, right? We would subtract equations from each other. The difference is that this one will be a little bit more systematized, and so we'll be able to get to the answer a little bit faster. So basically, we'll be doing a bunch of operations on this augmented matrix, right? Again, which is rewritten as this, and our goal is to get a system that looks like this. And so this is the equivalent of, right, X equaling whatever D1 happens to be, Y being equal to whatever D2 happens to be, and then Z being equal to whatever D3 happens to be. Okay, so that's what this tells us. This is our goal when we start off with this matrix right here. So first what we want to do is we're going to multiply the first row, right? Each row represents one of the equations, as you can see. So we're going to multiply the first row by the quantity A2 divided by A1, right? The whatever's here and whatever's here. And so we're going to write it like this. R2 is going to become row 2 minus A2 over A1 times row 1. And whichever row is getting replaced by the operation, you write that one first. So for instance, here we are replacing row 2, and we will be multiplying each one of these guys here by A2 over A1. Alright, so this is going to become, so first one, right, I'll write it out for you. A2 minus A1 times A2 over A1. And what happens here? A1's cancel, you're left with A2 minus A2, which is 0. And that's what you put in that first term here. And so what about this next term? Well, that's going to be B2 minus A2 over A1 times B1. And then C, the C2 is going to become C2 minus A2 over A1 times C1, as you see here. And then finally, the D term, right, D2 is going to become D2 minus A2 over A1 minus D2. And note that each of these terms here we're going to rewrite as B2 prime, and then this guy here we're going to rewrite as C2 prime, and then this guy here we're going to rewrite as D2 prime. Right, it's just going to be numbers anyways, right? B2 minus A2 over A1, B1, that's just going to be the result of that will just be some number. So we're just going to rewrite it as just some other number, just to keep things easy. Alright, so let's go ahead and look at the next operation. We want to eliminate elements in the third row. So we're going to use this operation right here, right? R3 minus A3 over A1, R1. So that is, we're going to be multiplying the elements in this row by A3 over A1, and whatever that all happens to be will be what the element from here minus that. So let's go ahead and take a look at the first element. So the first guy will be A3 minus A1 times A3 over A1, right? We're just grabbing the elements here and here. And note that when you work this through, A1 times A1 divided by A1, so we're left with A3 minus A3, which of course is 0, and that's what goes here. Okay, and now the next element will become the number B3 minus A3 over A1 multiplied by B2. And then the next element, oh, and note that, yeah, a little mess up, that should be B1 right there. And so the next one will be C3 minus A3 over A1 multiplied by C1. And then the last one will follow the exact same pattern. D1 minus, D3 minus A3 over A1 multiplied by D1, right? Again, it's just a number. And so we will again be rewriting these as B3 prime, and this one here will become C3 prime, and we'll write this one as D3 prime. Next, we want to eliminate the second element in the third row, right? And as you can see, we wrote those out here. See how it's recorded right there. All right, so we're going to eliminate the second element in the third row. So we're eliminating that element right there. That's the goal to eliminate. And so it's worth noting that in this step we were eliminating this guy, and in this step we eliminated this guy, right? We're systematically eliminating each element to get that identity matrix on the left hand side, right? Where we got ones along the diagonal and zeros everywhere else. Alright, so we're going to be performing this operation right here in order to get rid of B3 star. Note that it's whatever the third row is minus the element that we're trying to get rid of divided by the element that you see right there. Okay, so first one 0, 0 minus 0, of course that's going to be 0. Next element, the element right here, right, we're trying to make that equal to 0, and note that, element in R3 was B3 prime minus the number B3 prime over B2 prime multiplied by B2 prime, right, because that's the element right above it. B2 prime divided by B2 prime is 1. B3 minus B3, of course, is 0. And so we got what we were after. And so the element right here will become C3 prime minus C2 prime multiplied by B3 prime over B2 prime. And then the same with the next element. D3 prime minus D2 prime times B3 prime over B2 prime. And again, we're going to rewrite this number here as C3 double prime, and we're going to rewrite this number right here as D3 double prime. Now we're going to eliminate two different elements in this next one. We want to eliminate this element here, and then we're going to eliminate this element right here. So we'll look at this green one right here, and then we're going to have the orange one right here. And please note there is a slight error in the handout. This term right here, that should read C1 over C3 double prime. And then this term right here should read C2 prime divided by C3 double prime. So it's the right numbers, they're just transposed. So we want to get rid of these and replace them with what I've written in right there. Okay, so for this first operation, we'll be operating on these two here. Note they'll simply lead to a 0 minus 0 situation. So that just goes to 0 here. Easy enough. And then we look at the next one right here. Well, that's simply going to be b2 prime minus 0, so that's going to be b2 prime, right? Nothing's going to change. Now we're going to look at this operation right here. And let's kind of just work it off on the side for a second here. And again, this is this operation here, so whatever's in R2, which is C2 prime, minus C2 prime divided by C3 double prime multiplied by C3 double prime, right? Because that's what's in R3. And so C3 prime over C3 prime, C2 minus C2, the whole thing equals 0, and that's what we write right there, which is what we wanted. And of course, we're going to be replacing this element here with D2 prime minus C2 prime over C3 double prime multiplied by the element you see down here, which is D double prime 3. Alright, now we're going to work on using this guy here. Alright, so that's going to be whatever you see in R1, and we're going to be working on this one here first. So that's C1 minus C1 over C3 double prime times what you see in the third row, which is C3 double prime. Note that, that cancels to 1. We have C1 minus C1, which is, of course, 0. Okay. Now we're going to look at the next one right here. Well, that's going to be b1 minus 0, which of course is just 0. I mean b1 itself. All right, b1 minus 0 is just b1. And note we still have a1 hanging out right there. And over here, we're going to rewrite this as the number d1 minus c1 over c3 double prime times d3 double prime. Okay, and as usual, we will rewrite this as d1 prime, and this one will be rewritten as d2 double prime. Again, these just stand in for numbers. And now we only have 2 more steps. Okay, I've got a prime written on this one. That's not necessary to put that there because b1 prime would just be the same thing, so let's just kind of forget about it. It's just b1. Alright, so now note the number we're trying to get rid of is in fact B1. We want that guy to go bye-bye. So we're going to use this operation right here. We'll replace row 1 with the element in row 1 minus B1 prime. Well, again, that should just be B1 minus B1 over B2 double prime times R2. And just as before, that double prime really isn't necessary. We can just keep that as just a single prime. So that's just one prime right there. All right, because we don't have anything for that second prime. We go and just make that disappear over here as well. There we go. All right, so first element. We'll start off with right here. Again, that prime isn't necessary, so just kind of make those adjustments. We have A1. We're going to look at A1. So A1 minus what? Minus 0 is still just A1. So that stays. And then the next one, we've got B1 minus B2 prime times B1 over B2 prime. Those cancel. You're left with B1 minus B1, so you're left with 0, which is what we want. And then finally, this last one, 0 minus 0. And then we rewrite this term, the term that goes into there, like which was D1 prime, becomes the number D1 prime minus B1 over B2 prime times D2 double prime. And so we'll rewrite this number here as D1. Wait, hold on. Yeah, that prime doesn't need to be there either. So that's just going to become D1 prime. Okay, so let's go ahead and adjust these numbers as we should. That's just A1, and that's going to be D1 single prime. So mark that out. Alright, so we're going to perform these operations here because we want simply an identity on the left hand side. And again, this should be just A1, not A1 double prime. So R1, row 1 divided by A1 becomes simply, we have a 1 here, which is what we want, and this becomes D1 prime divided by A1. Second row, we use this operator. Sorry, something in my throat. This one we use this operator, and so that's a B2 double prime divided by B2 double prime, which is 1, and so this becomes D2 double prime, and that's a prime right there, okay, divided by B2 double prime. Last row, 1 here, and this becomes D3 double prime divided by C3 double prime. And so this would be the equivalent of x equals D1 prime over A1, y equals D2 double prime over B2 double prime, and then right here this would become z equals D3 prime over C3 double prime. And so in a nutshell, or probably not a nutshell, but in general, should I say, this is the method, right? Note that there's a lot of numbers going on, but there is a definite pattern to everything. So there's not a whole lot of operations to learn. You just kind of go down the list and you work it through as you go. So let's start off with this guy right here. First thing you do is you write the augmented matrix like this. And note that I write this with a square bracket, and this is showing up as a kind of a giant parentheses. They mean exactly the same thing. You can use the two interchangeably. It doesn't matter. Okay, so we're going to perform an operation. We want to get rid of these two elements right here. Note this is already a 1, so we aren't going to do anything to that one. So this first operation is going to be row 2 minus a negative row 1. So essentially we're just adding the two. And then the same with row 3. Row 3 is going to become row 3 plus row 1. Performing the, you get this right here. And you should be pressing the pause button in between each of these operations, trying to work them out yourself to make sure that you're getting the same number I'm getting, because that will be excellent practice for you. Of course, these top two rows stay the same, and then the third row becomes 0 and then 0, right, because we're doing negative 2 plus 2 times this guy, which is going to be 0. And then the third element becomes negative 1 and then positive 3. So you can see already that we see that z is 3. We want to get rid of, in the next step, this element here. And that element there. And we do this with the following operations. R2 minus R3, and then R1 minus R3, which will get the following. Of course, the last row stays the same, where we have second row 0, 1, 0, and then a negative 2 over here, right? 1 minus 3, negative 2. So we see that y equals negative 2, and then we do the first row here, which is 0, sorry, not 0, 1, negative 1, 0, and 3. So now we only have one more element to eliminate, which is this guy here. And we can do that simply by adding the first row with the second row. And of course, the bottom two rows stay the same. You know what? Let's go ahead and multiply this third row by a negative, so that we've got a positive 1 here and a negative 3 there. Make it clear that z is negative 3. I might have said it was positive 3 earlier. I should have said negative. And clearly y is negative 2. And then we perform this operation on the first row. So 1, go ahead and write plus, sorry about that. 1, 0, 0, and then negative 5. And so your solution is for x, y, and z are -5, -2, and -3. So plug those into the original equation here for all three equations, and you will get the left-hand side equaling the right-hand side. Okay, so we're going to run through this example one more time, but we're going to use a little bit of software to help us out. We're going to use the software Microsoft Excel. This is a very important program to make sure you understand how to use. It is used for a variety of applications. Given that you guys are all business majors, I guarantee you will use Microsoft Excel in your career regularly. Even if you are not a business major, this is a program you absolutely do need to learn how to use. So let's go ahead and open it up. And we are going to type in our augmented matrix, and I do highly encourage you to open up your own Microsoft Excel tablet while you're listening to this and follow the steps. Alright, so we are going to type in our augmented matrix: 1, -1, -1 and 0, -1, 2, 0, 1, and then here -1, -1, 2, and 1. Okay, let's go ahead and format this. We're going to go ahead and just, since we can't really put the brackets, I mean, I guess we could, but I think the easiest way to identify where our matrix is to just gray it out like so. And then let's go ahead and put the augmented part here. We're going to select the dashed line, stick that right there, and there we are. There's our augmented matrix. Alright, so we're going to go ahead and record our steps in here and here. They won't, effectively, these steps won't do anything, but it'll be notes to ourselves so we know what's going on from step to step. Okay, so first thing when you're doing the note, just type a space. Usually it'll work without a space, but sometimes Excel will want to turn it into some kind of operation that we don't want it to do. But if you do a space, it automatically makes it a text. So before you type anything that's a note to yourself in a cell, type a space. Alright, so what we're going to do here is we're going to replace row 2 with row 2 plus row 1. Right? Since when you add these two guys together, you'll get 0, and the same with this guy here. So come over here and we type row 3 is replaced with row 3 plus row 1. Right? We are trying to get rid of these two elements. So we come over here, and so we're going to want to keep this formatting here. So come over here. That was Control C to copy it. Right click, and we're going to select this guy here to get the formatting. And so this equals, right, row 1 stays as row 1. Drag that across. Alright, yeah, we'll have to redo that augmented line. And this is going to become row 2 plus row 1, right? We're just following our note that we made for ourselves right here. And sure enough, we get the 0 there that we wanted. Drag that across. And then we do the same here, equals our row 3, and we add row 1 to it. Alright, so once again we are trying to get rid of these two, and that is exactly what we did. Now we want to get rid of this element right here. Right, we're trying to get towards our identity matrix on the left hand side of our matrix of that augmented line. Alright, so come over here. Let's go ahead and bring that line back in. I Control C to copy, and now I'm going to right click and click on formatting. Get that line right back. Okay. So here we're going to replace row 3 with, right, type a space first. We're going to replace row 3 with row 3 plus 2 times row 2. Alright, that's our note. Come over here. This guy stays exactly the same. So row 1 is just row 1. Same with row 2. Alright, this thing will stop being goofy with me. There we are. Now row 3, that's where we do our change, right? Row 3 plus 2 times row 2. Alright, so you see that element is now removed, or zeroed out, should I say. So let's go ahead and Control C, get our formatting back. Alright, so the only thing here is that we want to get a 1 on the diagonals. Type it. This is where it's really important. Type a space. Negative row 3. We're replacing row 3 with negative row 3. Note that this is the same thing as multiplying both sides of an equation by negative 1. So come over here. This equals this guy. Well, hold on. Equals negative times that guy. There we go. So we see z equals negative 3, like we had before. And then the top 2 rows stay exactly the same. No operations happening to them. And let's get that line format, or that augment line, back in. Okay, there we go. Now we want to get rid of these 2 elements right there. And so we're going to do that by simply adding row 3 to both of them, right? 1 plus negative 1 is 0. So our row 2 gets replaced with, type the space, R2 gets replaced with row 2 plus row 3. And row 1 gets replaced with row 1 plus row 3. Alright, that's it. That's all there is to it. So click on the element, and then we add row 3. Same here, equals our row plus row 3. And of course the last row stays the same. Alright, so we already can see z equals negative 3, y equals negative 2. All we have to do now is replace row 1 in such a way where we get rid of this element here. So we replace row 1 with row 1 plus row 2. Since that gets rid of this guy and leaves the 0 alone. So row 1 plus row 2. And here we see that x equals -5. And then the other two rows stay exactly the same. Okay. And let's get our formatting back. Alright, I'm trying to type this on a trackpad, so there we go. Okay, there we have it. X equals -5, y equals -2, and z equals -3, which is exactly what we got right here, as we expected. Alright, so that's that matrix, or that system. So you can see how you can do it in Excel. Let's do this one again by hand, and then we'll do it in Excel. I really want you guys to make sure you do practice these by hand, but also, you know, be up to date on technology. Excel is a very good program. Make sure you understand it. So now we're going to augment this matrix. We note already that there are 3 variables and only 2 equations. So recall that picture that we looked at last time, where you could have like a line of solutions, right? So we're going to have an infinite number of solutions in this one, but it's not going to be just anything. It's going to be with certain conditions. So let's find out what those conditions are. And so we create our augmented matrix: 1, 1, -1, 1, 0, -1. I'm sorry. -1, augment it out, 0, 1. Okay, so those are our 2 equations. So we want to eliminate this element here, and so we're going to do that by replacing row 2 with row 2 minus row 1. This is 1, 1, -1, 0, and then we get our 0 there. Again, this is row 2 minus row 1, so this becomes -1, and then right here, -1 minus -1 is 0, and then of course 1 minus 0 is 1. Alright, so we've got our guy eliminated. Now what we want to do is take a look at this guy, right? We want 1s on the diagonal and 0s everywhere else, so we want to turn that into just a +1. So this becomes, row 2 will become negative row 2, so top stays the same, and bottom becomes 0, +1, 0, -1. So we can see that y equals -1. Go ahead and replace this guy now, and we do that with the operation replacing row 1 with row 1 minus row 2, and this becomes, let's go ahead and just write the bottom row in, since that stays the same, and then 0 minus 1, or 1 minus 0, I'm sorry. And then here we've got 1 minus 1, which is 0, and then -1 minus 0 is -1. And then +1 right there. So let's take a look at this in the terms of the equations. We have now x minus z equals 1. And we see that y equals -1. Okay. Solve this for z. -z equals 1 minus x. Multiply both sides by negative. Z equals x minus 1. And we report our answer like so. X -1 and then z is x minus 1. So you note that we have this equation set up where z is in terms of x and x is x, and this would describe, it's called a parameterization. Sometimes they'll replace the variable with the letter t, but here we're just leaving it as x, and this is the setup that you would have. So let's go ahead and take a look at this in Excel like we did before. Alright, so we're just going to reuse the same spreadsheet, and so we type in our augmented matrix 1, 1, 1, and 0. Next guy, 1, 0, negative 1, and 1. Alright, and we set up our, let's go ahead and borrow this again. And we're just going to go ahead and cut that last bit off. There we go. Alright, so we have our equation, or our matrix, should I say. And so our first operation is to get rid of this guy, which is already in bold. And so we do that by replacing row 2 with row 2 minus row 1. So again, row 2 minus row 1. Getting us that right there. Okay. Looks like I mistyped right here. This should be a negative 1. There we go. No big deal. This guy stays the same. And there we are. Okay, so we're no longer getting rid of that one, so that's okay. This time we want to replace this guy. We want him to be positive. Spacebar, negative row 2. So we're replacing row 2 with negative row 2, so equals negative this guy there. Drag him across, and then this guy stays the same. Okay, and just do a little paste special there. Okay, so we've got a 1 here, a 1 here, 0 there, so we want this to be 0. So we replace that with row 1 minus row 2. And when we do this, we get the following: row 1 minus row 2. Oh, hit the wrong key. There we go. And then of course this row stays this row stays the same. And there we go. So like I said, I really encourage you guys to utilize the software. Start learning it now. It will be very beneficial to you in the future. Alright, and so like we were, just as we were doing before, you can see that this matrix implies that y equals negative 1, and then we have the equation x minus z equals 1. and then we work it just like we did before. Alright, so back to the handout. Let's go ahead and take a look at this one. So let's write our augmented matrix. 1, 1, negative 1, 1, 1, 1, and then of course z is 3, and then we have zeros up there. Okay, so this one's nice because we already have a value for our z, so we're going to go ahead and try and eliminate that element there. And we're going to do this with the following operation. We're going to replace row 2 with row 2 minus row 1. Okay. And so row 1 stays the same. Row 3 stays the same. Now we do our operation. So 1 minus 1, that's 0. Next one, 1 minus 1, also 0. Alright, so next one, 1 minus negative 1, that's going to be 2. Alright, next one, 0 minus 0, well of course that's going to be 0. Okay, so note that we're not going to be able to get our ones down the middle, but we do have z equals 3 from equation 3, and then we've got z also equals 0 by this equation. So this would be an example of a system that does not have a solution, right? We're getting contradictory results. So we can say this, the solution does not exist. You can also note that if we were to perform one more operation, not necessary since we've already shown, but if we showed the operation by replacing row 3 with row 3 minus 1/2 row 2, right? Because that would get rid of, that would eliminate that one right there. If you do this, you know, top 2 rows stay the same. And then when you write 0, 0, because they're just zeros on the top, 1 minus half of 2 is going to be 0, and z still equal, oh, the third element still equals 3. We'll note that this third row here indicates that 0 equals 3, right? It's inconsistent. So another way that you know that there is no solution here. Alright, well that's it for the day. I hope you learned something. Make sure you stay on top of the homework, and I will catch you guys next time.